G'day and welcome to the Seacreatures Podcast, a show all about the amazing animals that live beneath the waves. Each episode we chat about a specific sea creature with a guest who has spent time and interacted with this specific ocean animal. Our guests range from marine biologists to underwater photographers, scuba divers, citizen scientists, and anyone with an intense passion for marine life. My name's Matt Testoni and I'm all of the above. And joining me for this episode of the Seacreatures Podcast is Erich Hoyt, and he is the author of the new book Planktonia, which is all about plankton, which is what we're going to be talking about today. And Erich's actually a whale researcher, and he's the co-chair of the IUCN Marine Mammal Protected
Areas
Task Force. Sorry for that.
It's a mouthful.
Welcome to the show.
Thanks, Matt. Great to be here.
So we'll start with a little bit about yourself. What gave you a passion for plankton, and has it kind of directed your career, or did you kind of just fall into plankton from somewhere else and just found it amazing?
Well, that's a sort of multi-pronged story. I mean, it has a long genesis of growing up loving the ocean, falling into whale research in the 1970s when we were first starting to learn about killer whales. It was particularly killer whales off Vancouver Island, and just being curious of every aspect of the sea and how we can protect it, keep it healthy. As you get involved with individual animals, you start to care about them in a way that, that it's not some abstract thing. And I remember one early thing with whales being out, we had these all-night whale watches, and we were just trying to monitor the behavior of orcas 24 hours. And we had this bay where we were camped, where they would come in. So I'd go out in the bay. We'd each take turns doing this, 3 or 4 of us. And we'd go out and we'd just sit in a rowboat all night long. And I suddenly became aware of all these amazing phosphorescent trails going through the water, as you'd see seals and fish going. And I, just started taking a light out there and shining it down into the water and seeing the kind of buzz of activity. It was just extraordinary. I had no idea about, vertical migration, or that all this plankton was coming to the surface every night. But by God, it was there. You didn't see it necessarily to the same extent during the day, but it was there at night. And that I kind of filed that memory in a way, through a long tangled path of working on a lot of different projects related to whales and marine mammals and marine protected areas over the years. I started to explore my, the sort of wider ocean, mainly through writing, through popular writing. And I did a book called Creatures of the Deep, which was mostly focused on the stuff near the bottom that I was curious about, and these expeditions to the bottom. It was a bit of history, and it was geology, how the plate tectonics work, and evolution. And it was all these things coming together to try to get a picture of what was going on near the bottom. And of course, since then we've had all these expeditions to the bottom of the sea, just in the last 4 or 5 years, with Victor Vescovo and Cameron from who made the Titanic movie, had his own sub. And but at the time I wrote the book, it was really a couple of guys back in the 1960s, and that was it. And why hadn't we gone to the bottom of the sea? So I had this curiosity, and part of that book was going down layer by layer. So I had a section in the surface layer and in the mesopelagic, which has all this wonderful, the light show, the bioluminescence, is at a higher level, more prevalent there than anywhere else in the ocean. Again, that was a kind of teaser for me. And actually part of that book was looking at the smallest organisms going to the largest. So I did start with phytoplankton, the plant plankton, going up to zooplankton and up to the larger species like whales that are actually eating some of that zooplankton. So there was that. And then I did another book that looked at layers, and I got introduced to some of these plankton photographers, that are doing the really small stuff. And that was my first taste of the Blackwater work. And it was Linda Ianiello and Susan Mears, who do work off of Florida, who are fabulous, going out every night. That got me into it more. And then I just decided, well, I've got to do a whole book on this, and talk to people in different parts of the world who are doing it. And that's the current book, Planktonia.
Yeah, and it's a gorgeous book. I've been looking through the photos, and I've done a little bit of, as you mentioned, we'll just clarify. So how a lot of people see these plankton and how you first saw them was with the light, and to dive with them, it's called blackwater
Yes.
photography, or I've even heard the term bonfire photography, which is kind of like that. And that's where you dive in the black with lots of lights. I just want to touch though on plankton before we dive into like the real nitty gritty and the awesome animals. But you mentioned there's kind of two main fields of plankton. There's the phytoplankton and the zooplankton. So talk us through what they are and any other kind of layers within those, especially the zooplankton.
Yeah. Well, plankton is this great big catch-all that is it's almost anything that isn't nekton, which is the kind of stuff that can swim on its own or is attached to the bottom, can be plankton. Plankton is the stuff that can't really make headway against currents. So, I mean, for a long time, I thought, well, plankton is stuff that just doesn't swim, but actually it does swim, and it does some amazing swims because it comes up from deep up to the surface every night. So it has to do a certain amount of swimming, but it's stuff that can't make a lot of headway toward, when there are currents out there, like fish can, of course. Lots of other species. So it's not a taxonomic entity. It's a kind of catch-all for a group of animals. And in fact, I go in the book into all the different sizes of plankton. You've got stuff that's about, less than the width of a hair up to some people consider sunfish to be plankton.
The adult sunfish.
The adult sunfish, yeah.
Oh.
Some people say the sunfish, they can swim pretty well, but they do an awful lot of plankton like floating around too, And it depends on the species of sunfish. Some are a little bit more lackadaisical, I think, than others. But they are, they can be considered plankton. And of course, the jellyfish, like the lion's mane jellyfish, which can be more than 100 feet long with the tentacles. And then you've got, I think the largest one that I found in the literature was this thing called apolemia, which is a siphonophore.
What's a siphonophore?
Well, it's like a colony. Yeah, it's like a colony. It's in the jelly family, and it's a colony, so it's all these things connected together. And they found it off Western Australia, and it was 300 feet long. It was about 2 or 3 times the length of a blue whale. They couldn't get an exact measurement because it was all curled up in a kind of defensive posture. But, technically you could say that was plankton too, So it's not just all the small stuff, but most of it is the small stuff. And the fundamental stuff, of course, is the phytoplankton, the plant plankton. And that's, responsible for a lot of the oxygen that we breathe. And this planet, life on this planet depends on phytoplankton. And everything in the sea depends on phytoplankton because you've got then the zooplankton munching on that. And of course, zooplankton, the zooplankton, munching on each other too, I mean, they're ravenously hungry, especially when they come to the surface at night.
It's a pretty tough life as a zooplankton, especially, I reckon. Like, it's a dog eat dog world out there for them.
It is. And that was, that was one of the fascinating revelations about the book about the, research into this was that there are different strategies the zooplankton uses. I'm going to say zooplankton sometimes and zooplankton other times. I think people, it's like zoology and zoology. People say it both ways. And I'm kind of mixed up Canadian living in Britain for so many years. So it's, but anyway, the evolutionary strategies that zooplankton use are different than what they use as adults. That's why they look different. So, if you're a zooplankton and you want to avoid being eaten, you might have huge fins, and barbels hanging down to distract the, from your chin hanging down. So you distract the predator. You might want to ride on a jelly. So you have your little protection, unit, that travels with you. You have all these strategies. For example, a flounder may have eyes on both sides of its head as a juvenile or as larvae, and these fabulous fins, that just like so flamboyant, looks like a peacock underwater. It's fabulous looking. But a lot of that is to fool, whoever's looking at it, make it look bigger and sometimes, or make it look different, so it looks like something else to the predator, like a jellyfish it shouldn't fool around with. But then when that flounder settles, heads for the bottom, becomes an adult, the eyes move to the left side.
Which is crazy. I've always found how flounders' eyes move. Amazing.
Totally crazy. And they become a different animal, really. And I mean, that was the other thing with a lot of this plankton. It's not just that it goes through one or two stages, but it's got multiple stages and looks different all the time.
Yeah, well, that was one thing I was going to ask you about, because I've done a little bit of black water photography and seen a few of these animals. And normally I'd ask a guest to kind of describe an animal and tell me what it looks like, but plankton are just so varied and they totally metamorphosize. But the question is, how do you actually identify what it's going to turn into? Like, are there any hints, or is it just hard work?
Yeah, there's a combination of hard work and using science in new ways. I mean, getting their DNA barcoding. But I'm going to step back first because I want to talk about how plankton were studied or have been studied historically. And that's they're collected in these nets by the side, by the side of ships. And what happens is that they get destroyed essentially by being funneled into the nets. And so it's really hard to, the delicate fins are mashed, and if they're gelatinous at all, they can turn into complete mush, like the salps and jellyfish. If you look at samples, traditional samples in museums, they won't have any pigment because they're in formalin, and the fins won't be there, So you're seeing something as larvae that it doesn't really look like even what the larvae looked like, much less trying to connect it then to the adult.
Yeah.
So there are fantastic planktonologists who are able to do all this and have a lot of clues. And actually having a couple of them from the Smithsonian, the National Museum, G. David Johnson and Bruce Mundy out in Hawaii, have been really helpful in giving identifications to the Blackwater photographers. But really what that's kind of started and is very exciting is a program to try and collect just a few examples of the species and then take the DNA. They can then try and match that to the adult fish. The other thing is actually the photographs are proving to be incredibly valuable because for many plankton specialists, they've never seen this before.
Yeah.
They're not necessarily divers. They're looking at the museum specimens. So they are really, happy to help with all of this.
Yeah. And so we've mentioned like Blackwater a few times, and that Blackwater photography is where you put a whole bunch of lights in the water and it attracts these plankton. And we've kind of mentioned migrations, how they move up and down. But tell us first, do the plankton move to the light because they're migrating? And why do they migrate? What's migration of plankton all about?
Yeah, good question. The migration of plankton, it's a great story, actually, how they first figured it out. There was Georges Cuvier, who's actually, I know from my whale studies, because the Cuvier's beaked whale that's found all around Australia and all over the world, he also had a hand in finding it, and it's named after him. But he was one of the first ones to notice in a lake plankton. There was a lot of activity at night, and it was continually happening. The next clue, I think, was in World War II. The German U-boats were using echo sounders in the North Atlantic Ocean and were finding that the bottom of the sea was going up every night. And they had no idea what was going on. But they'd find this, they'd send these signals out, and all of a sudden it was very shallow, and it wasn't shallow. They knew it wasn't shallow
Yeah.
because they were in the middle of the Atlantic, but they were getting these strange signals and just had no idea. But it was after World War II then that, by looking at lanternfish and other things, they started to realize that this was plankton coming up to the surface every night in such huge numbers, trillions and trillions and trillions. And not only that, but that it was happening everywhere in the ocean. It wasn't just some phenomenon, in a lake or in the North Atlantic or whatever. It was happening everywhere. And so what happens is that plankton, for a variety of reasons, I mean, probably a lot of it is that everybody else is, well, I was going to say everybody else is doing it. Well, I mean, that's where the action's happening, up in the upper surfaces, but it has to start somewhere. And I think they're hiding during the day because the upper area is lit, well lit up to 200 meters. And through the sort of cover of night, they can come up. They may have their own little light devices, the flashing and this and that. But as a result, all this other life comes up there too, squids and octopus and, larger fish, anything that wants to feed. We see a lot of whales and dolphins up at night feeding, and because there's a lot of stuff going on up there, and it's a good time to feed. This is what happens. It's, I call it the greatest migration on Earth. In terms of numbers, it has to be. We think of migration as being these whales crossing oceans and seabirds and monarch butterflies and all that, but really there's a lot more in the ocean, if you consider the breadth of the ocean in it and the fact that it's happening from the tropics to the Arctic, limited by ice, of course. But I think they end up mating in those upper waters sometimes. I mean, everything ends up happening alongside the feeding, but it's mainly feeding, trying to eat, and trying to avoid being eaten.
Yeah, so that's where the nighttime comes in there. They're hiding from the predators, but then preying as well.
Yeah, and that's what's driving the evolution and driving the behavior. And I think when you, as a blackwater diver, throw a light in there, that's going to attract some species.
Yeah.
And others are going to head for the hills. They're going to go down. So some species are attracted by light. That gives them signals. That's their language of light, I like to call it. Talk to each other with light. We don't know what we're saying or what, I mean, there have been people like Edie Witter, who's a fabulous scientist who's worked on bioluminescent, who talks about the way squid talk to each other with lights. And she's done experimental stuff of putting lights in the water and flashing them on and off, and can start to get to talk to them, as it were. I mean, it's quite exciting stuff. What are we doing with the blackwater lights? I don't know. One of the photographers in Japan, well, the main photographer in Japan, Ryo Minemizu, who's a fabulous photographer, who's so dedicated to blackwater. He's done like 28,000 dives.
That's insane.
Out of this world, really, in terms of numbers. He's so dedicated. Started, completely outside the field, but just kind of did it and fell in love with it. But he works out of Okinawa and sort of southern islands of Japan. He has a really interesting light system, not the strongest lights, but he figures he gets more with a kind of muted blue light.
Really?
Deep blue, yes. And the other thing is that he has a really strict system of not repeating the dives in the same place. And remember, he's only taking pictures of the tiny plankton, but he thinks it disturbs them if you're doing it too many times in the same place. He won't dive more than 7 times in the same place over an entire year.
Yeah. Same thing for like ports and especially a lot of cities and stuff. Like, I guess light pollution it's a bit of a random topic, but it is an issue. And it even affects even the smallest animals, doesn't it?
It is. I mean, we talk about light pollution in the skies, but it's an issue underwater too. And yeah, I think it's good for him to be sensitive to it. I haven't heard other people talk about it with that level of detail of what's good or not. That's the system that's worked for him. And so I don't know how much science there is,
Yeah.
but I think, precautionary is always good.
So we've kind of talked a little bit about like what they are and how they move, but one of my burning questions really has to be, what would your favorite plankton or favorite group of planktonic animals be? What's your favorite?
Yeah, that's actually tough because they're all such, amazing characters. And I mean, in terms of elegance, there's a photograph of the Mediterranean dealfish in the book, and I absolutely adore that photograph and the way that fish looks, that larval fish looks like it's like a race car.
Yeah, like describe it for us, like as best you can.
It just has undulating fins, and I think the photographer has got it in motion. It's Alexander Semenov, who works mainly in the White Sea, northern Russia, but spends time in the Mediterranean. So it was off Italy, and it has these colors, but it also has the fluidity of almost like a pencil going through the water with all these fins. I don't know. It's really hard to describe it.
A race car pencil with fins.
A race car pencil, yeah, and it has little, flaps and extra. It's definitely one of the fancy race cars. It's not like a stripped down version. It's one of the ones that has all the extras, attached to it to soup it up. It's gorgeous. But I like the porcupine fish as a juvenile is gorgeous. I mean, they're just a little ball of love.
Are they like a miniature pineapple? Would you describe them as?
Yeah, kind of. Yeah, or almost like one of those nuts that has a lot of spikes on it, and
Yeah.
but they have gorgeous faces, because a lot of these things, if you show them to general public, they think, oh God, that's ugly, or this or that. I always say that's a face that they have a mother, and that's a face of mother. But there's some that are immediately appealing to humans when you see them, and divers know that. I like the behavior ones. You get some of these slipper lobsters and the shrimp and everything that ride on the jellyfish. I think that's so fabulous. And they almost use one claw when they're young, and they take hold of a tiny jellyfish and they kind of wave it around, and it's like they're come and see me. It's a weapon. They've definitely figured out, in quotes, through evolution how to get by. And that's one of the ways. If you can avoid being stung yourself, and you can hang on to
Yeah.
this thing, and you've got a free ride. Sometimes it's great to see the interactions. I think what amazed me is that this is happening within a little tiny cube of the ocean. So these worlds. So, you as a diver go down, and the way Mike Bartik describes it, from Anilau, I thought was beautiful. You go down and you just focus on this one little section, and initially you just see a lot of blobs, or like tiny little blobs, specks of dirt, whatever. But then you start to focus in, and you get your lens going, and we're talking about species that are half an inch, quarter inch.
Tiny.
And I try to give the exact, or as much as possible, size of all these individuals, because that's in itself is amazing, that you're getting this detail on the body and color and everything else. But what we're seeing in the book is a giant version of that. As a blackwater photographer, you see that when you look through the lens.
Yeah.
I haven't done it, but I live vicariously through them. And I think it's just fabulous that this whole world is opening up. They also talk about being down there, looking through the camera, and then something big comes around, next to you. Really looks big. Doesn't seem to be too much, worry about that. Although, I think that was the initial big worry, that you're way out at sea, because most of this is not happening close to shore. Linda and Susan in the Gulf Stream go way off Florida into the edge of the Gulf Stream. It's 10 miles, 15 miles out. The depths are staggering.
Are the plankton moving from the bottom? Like in an area where there's 5 kilometers deep, are they sitting in like halfway down, or are they sitting right on the bottom and doing that migration every night the whole way?
That's a good question. I've asked it, but people don't know. We don't know. I mean, some of them, I mean, the enticing thing is that occasionally, I mean, Susan Mears talks about seeing a deep sea angler type fish come up one time into the surface waters. And, that's not, in a way, that's not supposed to happen, because they're adapted for depth, and, but this was a juvenile, and, they have different rules, and, who knows? So it could be fish that are, used to living a lot deeper than we think, or maybe they have their early lives in the top, 400, 500 meters,
before they settle.
Certainly in some areas of the world, there's a lot of, it's not just vertical migration. You might have vertical migration offshore, and then you have currents that are pushing that vertical migration in a horizontal way into an area like at Anilao, and to some extent in the White Sea. It's certainly not all deep stuff. There is stuff happening, quite high up in the middle waters that's coming to the surface. So I don't know. I think it probably varies in different parts of the world depending on what the depth is. I don't think there's evidence that things are coming up from the very bottom.
Yeah.
But there is certainly evidence that you have plankton, zooplankton in the black water, in the surface waters, that later on in its life settles at the very bottom.
Yeah, okay. So benthic stuff that lives on the bottom.
Well, it's sea cucumbers, for example, and so you will get settling, and even things like we were talking about flounder, and so there is movement, and I think that movement is tremendously important for the ocean. The regular vertical migration plus the whole process of these species living in surface waters and then carrying nutrients and carbon and everything else to the bottom. That's a really vital part of what ocean species are doing for us on the planet. There's a lot of sequestering, of concentrating of carbon and then taking it toward the bottom of the ocean, where it's not a problem to us in the way, and I think the ocean has done that service for us, always. And what we're doing is potentially, through pollution and acidity and all the other issues with the ocean, risking the ability of plankton to be able to perform that service for us.
Yeah, especially when you consider they're just the most numerous animal on the planet.
Must be.
Yeah, talk us through a little bit, just briefly before we wrap up, how the sequestering works. So I know there's a bit of a pathway with phytoplankton and zooplankton, but tell us why they are so important and how that works.
Yeah, well, so you have the phytoplankton, which is getting energy from the sun. The carbon gets sequestered through that process, gets put into the phytoplankton. When the zooplankton eat that, they take on some of that. When the whales eat the zooplankton, krill, blue whales eating krill and all of that, then they take that. When they die, those huge bodies go to the bottom of the sea, and that carbon, just stays down there, in the same way with fish that will, go to the bottom and live down there. So that's part of that story. But there's also recycling of nutrients that happens, all of this stuff that's vertical that goes on, both the migration and the sort of birth, life and death, is incredibly important. And it operates in a different way than on land, because land doesn't have it just doesn't, it's not like the ocean. We're a water planet, that's really where we're at. It's it's important that we look at this. One part of at the end of the book, I look at protected areas because that's part of my focus with whales and marine mammals. And I think that we should be looking at protection of plankton, some of these extraordinary areas where you have the vertical migrations going on and you have special species. Around Hawaii, you get a lot of unique species because it's so remote from everything else. In the Arctic, you have different species, a lot of sea butterflies and things you don't get other places. I've got a kind of taster of different places in the world, focus on 5 places in the book. And that all those places, I think there were only 2 that had any kind of protection. And also the kind of protection they need is probably going to need to be more comprehensive than it is at the moment because it's very superficial. It's literally surface. So when you talk about protected areas of the ocean, you're talking about the surface area. You're not necessarily talking about the bottom or the middle layers. And we really need the whole ecosystem. It has to be ecosystem protection.
And it's interesting because, you describe like phytoplankton are like trees, they absorb that sunlight and that carbon. And we're all about protecting our forests and fighting climate change with that. But the greatest forests are pretty much these tiny microscopic trees that, are plankton. And it's a really interesting, like an unseen world.
You've said it perfectly. I mean, the unseen world is most of the world. We're just on these little specks of land, these little islands on a water planet, and we need to realize that.
Yeah, definitely. Well, before we kind of get to the end of the show, have you got any really cool facts about plankton, or just interesting facts about plankton?
Yeah, I don't know. I think I've thrown so many interesting facts all along, probably too many.
Nah, never.
Yeah, never. Yeah. Let me think. I'm sort of looking around and thinking. So I think for me, the evolution and the development, first of all, because development teaches us a lot actually about evolution, because if you look at what species look like when they're in their infant stages, their larval stages and even egg, and before that, that's when they kind of reveal what clan they're in, what kind of bigger club they're in.
Yeah.
And then as they develop, it kind of narrows down a little bit, and you can see this in all species. It's not just plankton and it's not just water-based, land-based as well. You can start to piece together by looking at all these stages, what are the evolutionary factors that drive the way they look. But we just don't know that much. We're just learning. And I'd love to come back to this book in another 5 or 10 years. I came back to one of my earlier books, Creatures of the Deep, after 20 years and rewrote it and added another massive chapter and everything.
Were there any errors or anything that like you were like, oh, we thought that, but it's not?
Well, some of it was historical because we didn't actually know how deep the Marianas Trench were. And now there's still a lot of debate about it. So we probably still don't know that. But Victor Vescovo, who's, currently doing these amazing dives in all the deepest parts of every ocean and taking people down, all over the place. I mean, it's just gone to a whole other level. From what it was until now, till the last 5 years. He's measuring and coming up with statistics that are different from James Cameron and different from the original explorers and different from some of the remote subs that have gone to Marianas Trench and some of these other areas. So, we don't even know how deep the ocean is on our own planet. In the first edition of the book, I said we'd mapped less than 1% of the ocean, and I think that was fairly accurate at the time. But we have actually mapped quite a few more percentage points. Now I forget exactly what it is, but we are, we are still at the very beginning of our knowledge. We know less about it than some of the planets, but getting to know more about the deep sea. We're so lucky to be at the dawn of all this.
Yeah. Well, that kind of brings us right to the end. But just before we wrap up, if people want to see different plankton, either through your amazing book, which has some incredible imagery in it, or if they want to see it in reality or learn more about it, what should they do and where should they go?
I mean, certainly you can see plankton in aquariums. You can see jellyfish, and in the wild, there are now diving tours that take people out at night. You want to be an experienced diver. There's a company called Pura Vida off Florida, is one of the two companies in southern Florida that's taking people out. There's Crystal Blue Resort in Anilao in the Philippines for 6 months a year. Mike Bartik, who started the Blackwater Photo Group, which is on Facebook and Instagram, which is a fabulous way to tune into all this stuff. The Blackwater Photo Group, anybody can join. It's a public group. And you can submit your photos, if you're enthusiastic and you're starting to do this in your backyard, so to speak. But there's so much out there that's developing. It's all recent. We're talking about the last really handful of years. There's some nice books out besides mine. There's a guide to all the fish and plankton in Hawaii and blackwater diving, Field Guide to Blackwater Diving by Jeff Millison. And there's a couple of editions of a wonderful book by Linda E. Aniello and Susan Mears called Blackwater Photography. I'm happy if people also want to investigate my book and look, and learn about some of the different people who are doing this in different parts of the world. Planktonia. Can I talk about the title for 1 minute?
Yes, please, because that has interested me a lot.
Yeah. Planktonia is not a word in English. I'm so pleased to invent a word. It's not, I haven't invented the word really. It's a Finnish word for plankton. But what I wanted to conjure up with Planktonia was the idea of all these plankton coming to the surface at night along with all their predators. So to me, that's the world of plankton. And it's sort of, it sounds like a kingdom, Planktonia.
It does, doesn't it?
Yeah, and I thought, well, that it is a kingdom, and so I feel great that word is sort of, I sent it to my publisher, and I thought, oh, they're going to say no, that's not even a word, how are you going to name a book? And publishers get the last word on titles.
Yeah, it's such a cool book. I've been having a look through, and it's helped me identify a few of the animals I've seen doing blackwater photography. And when does it come out in different parts of the world?
The book, Planktonia, is out in the US and Canada now, and it comes out in UK, Europe, Australia, New Zealand, early November.
Yeah, and I'll post all the details about what we've talked about in the links, including the link to your book. It's been awesome. Thanks.
Thank you.
Seacreatures Podcast is hosted, edited, and produced by myself, Matt Testoni. You can see my photography on Instagram at Matt_Testoni_photography or my website, mtunderwatermedia.com. Production assistance by George McGrath and music by the talented Dan Musil. Check out more of Dan's work at danmusilmusic.com. If you've liked the show, jump onto our Patreon account, patreon.com/SeaCreaturesPodcast, where you can give a little donation each month to help the running costs of the show. Also, if you're a fan of the show, don't forget to give us a review on whatever platform you use to listen to the podcast. Tune in next time on the Seacreatures Podcast to hear all about jellyfish with our special guest Scott Morrissey, who studies their DNA. This is the Seacreatures Podcast. Over and out.